Students, greeting of the day and welcome to this video again. In the next 15 minutes, we'll be dealing with the close packing in 2 dimension and 3 dimension, how in 2 and 3 dimension the close packing takes place and what are the advantages. That all will be dealing into this video lecture.
So in close packing in 2 dimension and 3 dimension students, it's basically the phenomena of a dimension, that is the height. So length and breadth, if you are increasing, that is 2 dimension. So in 2 dimension, when we talk about close packing, because of the atoms which are arranged in such a manner that the centers can be horizontally and vertically in a line, or they may have an inclined arrangement. So there we get concept of coordination number, that is coordination number 4 and coordination number 6. Now here you can see, students, in the close packing in 2 dimension, when we are talking about, here you can see white balls as well as the shaded balls. So basically the center where the cross is formed, that is the atom which is considered to be the reference atom, and from that reference atom we calculate the coordination number. Coordination number is nothing but the number of atoms which are directly joining the reference atom, that is known as coordination number. So here that white atom which is at the center is joined to 4 atoms directly, and those 4 atoms, their centers are there into that geometry which is formed. So that is coordination number 4. The constituent particles, the spheres, can be arranged side by side with each other in the row. The row can be combined in 2 ways. First one is the spheres are packed in such a way that the horizontal and vertical alignment is there. You can see the centers are aligned in such a way that horizontally if you see or vertically if you see, they are perfectly aligned. In this arrangement, the spheres are found to form a square, and this type of packing is also called square close packing in 2 dimension. And this geometry having coordination number 4, when combined with another geometry of the same type, then these two at a distance when joined, they are said to be the cubic geometry which will be formed in 3 dimension. Now the second type of arrangement can be the spheres are packed in such a way that the sphere in the second row are placed in depression between the spheres of the first row. Similarly, the spheres in the third row are placed in the depression between the spheres of the second row, and so on. So this gives a hexagonal close packing arrangement. Now basically what I tell you, if the atoms are into the horizontal and vertical alignment, if you force the topmost atom, so the space which is there in between the atoms, that space will be occupied, and when that occupied space is taken up, so there that will be the sphere which will be going, or the atom which will be going, and hence now the earlier it was something like a straight vertical and horizontal, now it has been inclined. Now these are the inclined lines you can see, and these inclined lines, they will be having a variation, that is now the coordination number will change. This is the reference atom you can see at the center. Now these are the 6 atoms which are touching this reference atom, and henceforth the coordination number has become 6, and this is known as hexagonal close packing arrangement in 2 dimension. Coming to students, now the close packing in 3 dimension. Now in 3 dimension, actually what is happening, the layers will be there, and those layers will be demarcated as A and B. So let the spheres in the first layer be A. In this layer 2 types of voids are present, small a and small b. Now let us place the spheres on void B to make the second layer, as you can see in the second diagram. So those dotted lines are coming over only the B small b voids, and henceforth the second layer is formed, which is said to be capital B. Now when the third layer is added, 2 types of voids are present, which are marked as A and C. So there are 2 ways to make the third layer. The first one is the third layer may be placed on the void C, So the spheres of the third layer lies directly above those in the first layer. Due to this, third layer is identical to the first layer A. So this type of packing is having similarity, that is the first layer is similar to the third layer and the second layer is different. So over here into this arrangement, this is hexagonal close packing arrangement, which I said is three-dimensional. Now which was coordination number 6, those two layers. Now you can see this is the first layer, this is the second layer. Now hexagon means 6 atoms and 1 at the face center, so that will be 7 at the top, 7 at the bottom, and 3 centers are only considered over here into this geometry, where it can be 6 also. But 6 becomes complicated and that is not observed in examples. So later this were considered as only 3. So that becomes total as 17 atoms which are there, and these 17 atoms are required to form the geometry. Out of 17, 14, that is 7 into 7, they are used up in 2 different layers. They are said to be A. Now here one more thing, students, you can see clearly these are the 2 atoms which are seen totally. So here these are the 2 atoms. So the atoms which are in front towards us, they'll be seen totally, while here you can see 3 atoms which are peeping out, they are half seen or 3/4 seen as per the placement. So these are the ones which are behind. Now this you can very clearly understand by keeping this 7 balls or table tennis balls and joining them like a hexagon and keeping one at the center. When you see from the front, you'll see only 2 balls totally, while the other balls will be peeping out. A similar type of example you can see at the time when Ganesh Chaturthi comes. These laddus which are kept, they are also having the same parameter. The ones which are towards you will be seen totally, while the ones which are in between or at the back will be peeping and they will be seen half or 3/4 of it. Similarly, here in the second layer you can see these 2 atoms which are in the front, they will be seen readily, while the one at the back will be peeping out. So this is the arrangement as ABA arrangement, which is for hexagonal close packing arrangement. Now coming to the second type by which we can place these atoms, and the third layer is placed on the void A, which gives rise to the new layer C. However, it can be shown that the spheres in the fourth layer will correspond to those in the first layer. This type of packing is represented by ABC, ABC. Means there is a repetition of, as in the previous one there was a repetition after B. Here repetition is after B and C, but B and C are directly opposite to each other. Means the arrangement is slightly changed while the number of atoms remains the same. Here in A you will see only one atom is there at the center, but in the case of B layer you will see this atom over here which is totally seen, while the 2 are sideways and the 3 are into the layer which are the corners of the cube. Here the 3 which you see in the front, these are the ones which are readily seen. So students, this is basically the formation of layer in the close packing arrangement, that is known as face centered cubic geometry. Now as we are aware of the fact which we have dealt in the previous videos, that for corners we require 8 atoms. So those are the 8 atoms and 6 faces are there in the cube, so that becomes 8 plus 6, 14. Now those 14s are arranged into such a way that 1 are in A layer, while B layer has 6. So 6, C also has 6, so that is 12 plus 2, 14. So these are the 14 atoms which are there, which are arranged in such a way that they are seen into that parameter. Now students, one more thing very clearly, the one which you see as the diagram which is on the left hand side, so this is the basic structure which the scientist obtained while observing a cubic geometry or the compound having cubic geometry on electron microscope, and they as per the map. In the map what happens is the kilometer which is in say hundreds of kilometer, that is shown by just a line of 1 centimeter. So similarly uh, what is that? That is basically a ratio. Okay, 100 kilometers on land will be equal to 1 centimeter on the map. Similarly, what they did on the actual parameter, they segregated these balls by the dimension, that is taking the balls away, taking the spheres away. So when the spheres were taken equally away, lengthwise, breadthwise and heightwise, it was the geometry which was formed as the cubic geometry which you see on the right hand side. That is for all the geometries. Actually, these geometries are nothing but the atoms are joined in such a way that becomes easier for us to understand. Seeing the left hand diagram, you cannot say that is a cube, but seeing the right hand side diagram, you can say that yes, it's a cube, because that cubic geometry is nothing but that is the expansion of it in the ratio, and then the atoms are joined for the simplicity so that it can be a specific structure which can be seen by us. So students, that is regarding these geometries. So let us recapitulate or revise. We have dealt with the close packing in 2 and 3 dimension. In 2 and 3 dimension, we have taken the coordination number 4 and 6 in 2 dimension, and as per that we have formed hexagonal close packing arrangement and face centered cubic geometry for the 3 dimension. So student, this is something imaginatory power is required over here so that it becomes easier to understand the concept. Henceforth, just go through the video twice or thrice, then get ready for the questions which will be coming into the questionnaire session and the numerical session. So thanks a lot for listening and take care of yourself. Bye and be happy, be healthy.